This video is a follow-up to class today. So we were looking at this acid-base reaction. So this was from our homework, and we're trying to figure out what are the products of this reaction. Then we need to balance it, and then we need to write the net ionic equation for this reaction. So the first step we're going to talk about first, and then I'll give you some hints for writing net ionic reactions sort of generally, and then we'll apply it to this problem. Alright, so first we needed to predict the products, and we worked this bit in class, but I'll go through it again. So this is an acid, phosphoric acid, and it's not on our list of strong 7 acids that we've memorized, so we know it's a weak acid. Then we've got this guy, barium hydroxide. Now because it contains hydroxide, and it's soluble, we know it's soluble because, well, in this question they've written AQ beside it. So if it weren't soluble, if it didn't dissolve in water, that's what we mean by soluble, then it would have an S indicating that it just exists as a solid at the bottom of the beaker, right? So because it has hydroxide, we know it is an Arrhenius base by the Arrhenius definition. So it has hydroxide, it's a base. So this is an acid-base reaction. So how do we work these acid-base reactions? So remember what we do is we exchange the cation parts. So the H plus from the phosphoric acid is going to exchange places with the metal cation part of the barium hydroxide. So we're just going to exchange the cationic parts. So these guys just trade places. So we're going to end up pairing the barium right here with a phosphate. And in order to get the formula right, we need to know what the charges are here. So we notice that barium on the periodic table is in group Roman numeral 2A, so that means it has a +2 charge. For phosphate, we've memorized that it is a -3 charge, but we could also figure that out from this formula because we know the H's here. Thinking of this as an acid, each H has a +1 charge, so we got 3 of them, so that must be offsetting the -3 charge on the phosphate. So then we're going to write for our formula up here, Ba, and then we cross our charges, remember, so we're going to bring the 3 down as the subscript on the barium, and the 2 is going to come down as a subscript on the phosphate. So it's going to be Ba3, PO4, 2. Alright, so there's one of our products. Now, we need to figure out a phase label to write next to this. So you're going to have to type in your phase labels on the homework or it won't count it correct. So we're going to need to figure out whether this is aqueous, solid, liquid, what? Gas? We'll come up with that in a minute. So let's think about the other products. Now we've taken these H's, we've moved them over here, and now they're paired up with the OH. So H plus OH gives us H2O. Right there, so H2O. Now H2O is the solvent in this case, so we know that water is going to be a liquid, so we can go ahead and write the phase label, that L, right there for liquid, for water. Alright, so now we've predicted the products, now we just need to balance the reaction. So looking here, I'm going to start with the bariums because it's only in one other place. The hydrogens and the oxygens kind of are all over the place, so we'll do those last. So barium, I've got 3 bariums here, so that means I need to put a 3 in front of this formula right here. Now for polyatomic ions, I usually think about those guys hanging together as a group. That makes it easier to count. So, and that's just a little tip when you're working these kind of balancing reaction problems. Keep your polyatomic ions together because they usually stay together in the reaction. So here, I've got phosphate, and the parentheses are telling me that I've got 2 of them. So I've got 2 phosphates on this side of the reaction. Over here, I've just got the 1 PO4 unit, so I'm going to need 2 of those. I'm going to stick a 2 out in front here, so there's a 2. Alright, so I've got 2 of these phosphoric acids. Good. So now I'm ready to look at the hydrogens and the oxygens. So the hydrogens and the oxygen balance I can all sort of take care of here. So if I think about the hydrogens, I've got 2 times 3, so that's 6 hydrogens from the phosphoric acid. Then over here in the barium hydroxide, I've got this OH2. So each one of these has 1 hydrogen, but I've got 2 of them. And then I've got a total of 3 of these barium hydroxides. 2 times 3 gives me another 6 hydrogens. So I've got a total of 12 hydrogens, all total. So to take care of that, I've got to have over here 12 hydrogens, so I can do that by putting a 6 in front of the water. 2 times 6 is 12. And so now it looks like everything is balanced. Let's just check to make sure. So the oxygens, we can just worry about the oxygens that are over here because I've counted for the oxygens in the phosphates already. So here I've got 2 times 1 is 2 oxygens times another 3. So 2 times 3 is 6 oxygens and 6 oxygens for the 6 water molecules. So that all looks balanced. Okay, good. Now we've got the balanced chemical reaction. So now all we have to do is go in and figure out these phase labels. Barium phosphate, what is that? Is it going to be a solid, liquid, or a gas, or aqueous? That's the question. Well, probably it's not going to be a liquid because these are ionic compounds, and to be a liquid they have to be above their melting point, and ionic compounds don't melt until you get to like thousands of degrees Celsius. So probably not going to be a liquid. Not going to be a gas either for similar reasons, right? Get it into a gas phase, we have to get it even higher, and probably it's going to break down before you do that. We're kind of stuck with, is it a solid or is it aqueous? Well, that all depends on knowing whether or not barium phosphate is soluble or not. Now, we haven't quite gotten to this section yet in our textbook, but I'm going to give you a little brief overview of this, not a review because we haven't done it yet. So in Chapter 4, in the section on precipitation reactions, we're going to learn some solubility rules. These solubility rules will help us tell whether or not things are soluble. So let me give you some of these solubility rules. And this is my summary of what's in table 4.5, and that's on page 155 in your textbook. So these solubility rules. So things that are soluble. So we need sort of a list of things that are soluble. So what things are soluble? Any ionic compound that contains group 1A metals. So if you've got an ionic compound that contains lithium, sodium, potassium, those guys, you're going to have something that will dissolve. So right now, barium phosphate, we don't know because barium is not a group 1A metal. It's a group 2A metal. So what are some other things that are soluble? Some other things that are soluble are the group 1A metals and ammonium cation. So these are things that are cations, so that's why they all get lumped together. So if you have something that has the ammonium cation, NH4+, so if you see this NH4 group, those guys are going to be soluble. On the other side, anions, we've got nitrates are soluble. All nitrates are soluble. Also, all acetates are soluble, so CH3COO-. So all acetates are soluble. So any compound that contains these anions. Now here's some anions that we're also going to list that are soluble, but there's some exceptions. So the halides. So this is chloride, bromide, fluoride, iodide. They're in group 7A. So halides except, so I'm going to write EXCPT, except the halides of silver, +1, copper 1, mercury 1, and lead 2+. So there are kind of some exceptions here. So most of the halides, so like anytime you have a chloride paired with something, it's pretty much going to be soluble unless it happens to be paired with one of these metals, and then it's going to be insoluble. Some other ions that give you soluble things are sulfates. So anything paired with sulfate, SO4 2-, and again there's some exceptions that we have to worry about. Exceptions, and the exceptions are barium, strontium, and calcium. So if you look where those are on the periodic table, they're all in group 2A, and they're sort of the heavier of those metals. They're further down in the group. The other things that aren't soluble, mercury again and lead. So mercury 1, Hd2 2+, and lead 2+. So those are the exceptions for the sulfates. All right, so this gives us a list of things to expect when we are going to have a soluble compound. So notice up here, it's not looking so good, right? So none of these things correspond with something that we have. So we haven't learned about phosphates yet or barium. So I'm going to scroll down here and we're going to write down some rules for some insoluble things. So right now it's looking like barium phosphate is going to be insoluble. So insoluble. All right, so the things that I write down in this list for insoluble, so things that will not dissolve in water, you have to remember that if they're one of these things up here, then they're going to be soluble. So any of these ions that I list, if they happen to be paired with like a group 1A metal, that makes them soluble because those are always soluble things. So insoluble things, hydroxides. So anything that is a hydroxide except the things that I listed above, so like the group 1A metals, and here are the exceptions. Calcium hydroxide, strontium hydroxide, and barium hydroxide. So those, again, are the heavier alkaline earth metals. These are exceptions that are going to make it soluble. So in that case, the hydroxides are all insoluble and won't dissolve in water except for these guys. Next, sulfides. So those are things with S2-, and our exceptions are, again, those things we've talked about up here, the group 1A metals, the ammoniums. There are exceptions. Calcium, again, strontium, again, and barium, again. So those guys are exceptions. Carbonates. All carbonates are insoluble, and there are no exceptions. Phosphate. All phosphates are insoluble, except, and there are no exceptions. Again, when I say no exceptions for carbonate and phosphate, that doesn't include those things that we listed up here at the top. So if you've got, let's say, ammonium carbonate or ammonium phosphate, that's going to be soluble. Or group 1A metals, so like potassium carbonate, potassium phosphate, those are going to be soluble. All right, so based on our solubility rules, then let's scroll back up. Phosphate. All phosphates are insoluble unless they've got these guys. So this stuff right here, insoluble. So we're going to write an S beside it. So now we've got all our phase labels. And so this is the equation that you should have entered into the smart work assignment. How did we know this was insoluble? We had to use our solubility rules to figure that out.